Good afternoon, my dear students. Now we will perform the practical based on backpropagation algorithm. So, as we discussed in the class, what we are going to do is first we will go through the file which I have already provided to you. So what you have to do is backpropagation is our third practical. So first you have to implement the binary sigmoidal activation function and its derivative function for backpropagation using MATLAB. So how you can do is so all of you listen. How you can do this is, see, binary, the same name, I hope you know, binary sigmoidal activation function. So how binary sigmoidal activation function, y is 1 by 1 plus e raised to minus x. Similar way, the derivative of that, so derivative of binary sigmoidal activation function, that is function y binary sigmoidal x, y is equal to, that is b into binary sigmoidal into f of x into 1 minus f of x, right? So that it is the same thing, so that you can write it here like this. Then first a is nothing. Okay, I hope I haven't see, you can do it in any way. This is only one way I'm telling you. Okay. So I'll repeat it. First, what you have to do is, in your write-up also it is mentioned, you have to implement binary sigmoidal and its derivative function for backpropagation. Then you have to implement exclusive OR algorithm. What is exclusive OR algorithm and everything, you know it. Now we'll not go, because each and every time we are explaining 1001 like that, we will be to input exclusive OR gate implementation. That is what we are going to do using or with the help of backpropagation network. Now you can go through the theory and details, because since from the morning we are doing the same thing, I'm not explaining that. So the steps you have to follow, basically 3 steps. Initialize the weights, that is whatever the existing weight that you will be using, till the stopping condition is false, or stopping condition jab tak false hai, till the stopping condition is false, you have to do the training first. So in training we are having 3 phases: feed forward and backpropagation, error find out karna hai, and then you have to update it. Once this is done, that is there in training phase. Okay, once the training is done, next is the testing. Okay, so in testing we are having only one phase, which is feed forward. Okay. Okay, now I am going to just execute and show how exactly it is working. So that is 3a. I'll repeat, those who are latecomers, for them. We have to first do the activation function for binary sigmoidal. Then we have to write the function for derivative of activation function for binary sigmoidal. Then we have to go 3a and 3b. 3a is for training, implement exclusive OR using backpropagation. This is training data, training code. First we have to do the initialization, and then I'll just execute first and show, then you will understand how exactly it is working. That you could see the loading data and initiating the weight and bias. So x is the input 11100100. What is the target? That you know that if it is 11 it will be 0, for 1001 it will be 11, and for 00 it is 0, that we know. So the target is the same data, whatever the way the 2 inputs are, accordingly we should get the output for exclusive OR gate implementation, correct? So when you so first point, I think everybody will be able to do it. I've done program post 2 enter to continue, because there is, it is lengthy. Each and every epoch, whatever in the morning what we have discussed in the problem of it, is only for epoch 1. Like that we will be doing it. If you see this, this is a epoch 1 to, this will be varying depending upon like the condition, correct? So epoch, this time the condition what we have given, that we have to check, I'll tell you. So this is error is less than point 5, 0.005 say less, say 0.005002. If the error is less than 0.0049, then we will be stopping it. Okay, so you could see the condition for that. Then we will check how. Then final weight updation at that time. So each and every epoch, whatever the error is coming, that will be calculated, and then it will go for the next epoch. Next epoch again the error is calculated. So it is the same or similar network which we have used. So whatever the weight updated here, okay, whatever the final weight updated here, this we have to take it. That is v b1. b1 is bias. Okay, v is vij. Vij, how we will be writing this one should be, okay, I hope we have discussed in the morning, but still I'll just let you know how exactly it is working. Okay, so as it is, I'll not be able to copy. Maybe I have to copy from the program. So what we are doing is, we are getting the, we will come to it. So what is happening initially, whatever the input that you can paste it, and after that at the end we will be displaying all the updated weights. That is what, this is training phase. Okay, suppose this is the example. I'll not be able to write here, that's why I'm just taking. I hope is it visible here? No. Let me just check. Okay, give me a minute. Okay, so what I have written is, I have taken the output from this. So whatever may be the for exclusive or implementation, for maybe it will be varying. Okay, depends upon how many epochs. So the training should be proper. More and more times if I am executing, there will be some variations that you could see. Okay, once bpn and everything is over, then it will be calculating the total epochs performed and the total error, final weight matrices and bias. So Vij, this is what I have to tell here. If you see this so here what we are getting finally is Vij. Maybe with this. Okay, so this will be Vij. So in this it will be 1 2 1 2. So V11 will be this, V12 will be this, V21 will be this, V22 will be this. I hope you understood. So this is Vij. So this will be 1 1 1 2 1 2. So 1 1 1 2 2 1 2 2. So all the matrices, if I am having whatever we have discussed in the morning, so I am not discussing the same thing. So 2 input, again 2 input and 1 output. Okay, so in this case we will be having v will be 2, correct, for this. So this will be total v, that is for 2 input x1 and x2 and z1 and z2, and similar way for that, what is the bias? Okay, I hope you remember the diagram. So the bias value for this z1, one bias will be there. I'll just show you. I'll just take that ppt, so it will be easy. to explain. I have already uploaded the PPT, so all of you can see exactly what is the output you are getting and all, and how to calculate it, how to find out that. We'll take the same problems, diagram. Maybe this, fine. So that will be easy. It is not, I don't think it is the same value which we are implementing. So whatever is there. So maybe this kind of diagram, okay, it is not the same diagram. So initial weights, whatever is there, everything is changed now, whatever the weight which we are giving. And after that, so I hope now all of you remember what is this. This is V and this is W, and we have taken I, J and K. So uske accordingly, so V1, V2, this we will be finding out. Similar way, we will be having this and this. So two biases. So that is V1. Similar way, we are having here W1 and W2 and one bias. So W1, W2 and one bias. Okay, so this is how, this is for one epoch we have found. Now how many epochs we are finding? We are finding for some condition criteria we are giving, and we are checking for condition whether that is working properly or not, or whether that we are getting according to our condition or not. So this is nothing but in here you are getting. Now what I suggest is once whatever the here in this case, if you observe, I'm getting little bit different, right? In the first time when you execute 3810 times epoch total number of epoch performed is 3810, and the condition which I have given is 0.0050 error tag. Less than that, we stop it. Okay, then the final matrices, if you see, you can see some kind of this value. I can give the same value, but what you have to give is whenever you are getting the latest updated value, from where you will be getting that? From this. Okay, here there are slight changes. And let me just check. So what you have to do, you have to take this, copy this, and then you have to update your 3B. What is in 3B? We are doing testing. What we are doing? Testing. Testing में क्या है? What we were saying, backpropagation का testing में only one phase. What are those phase? That phase is we are having the load will be only forward phase. So whatever the load, this one, can you see this? So uske accordingly you can update it. So here the value of V, suppose the same thing if I take maybe this one, I'm not sure. Let me just check. Okay, so it will be varying then. Let me just check. Oh, it is the same thing. What we have got is the same thing. Okay, answer is same, almost same. So I'm not changing. Otherwise, you can just change the value of B is here. Whatever the V is the updated weight between input and hidden. B1 is the those bias values. B1 two bias values. W is W1 and W2, that is from hidden to the final output. Okay, B2 is its bias, that is W0. So the threshold which we can set again is, presently I have set it to 0.5. You can set it to anything. You can vary and see accordingly where you are getting the best result. So I will execute this. Rest everything will be according to the algorithm. We will come to it. So you can see that what we are done is the same W and all this value. What we are getting is this. So can you see this? Threshold is this. Loaded input is 1 1. For 1 1, what is the target value? 0. So I am getting the output from back propagation also 0. For 1 0, what is the target value? Supervised learning 1. So I am getting 1. 0 1, I am getting the target value as 1. I am also getting this one. 0 0, target value 0, and this is 0. Means I am implementing actual that is worked for training as well as for testing. So this is how the program has to be executed. Now going in depth. Okay, going in depth the program, that is what I'm going to discuss very quickly. If you have any doubt, you can unmute and ask. What I suggest is these programs, if you want, you can take the help of it. It is already uploaded in the drive. Otherwise, you yourself can do it. There is no nothing like that ki you have to do it in the same way. So what I suggest is 3a. First is initializing weight and bias. You could see the whatever the total number of neurons which we have set up the parameters, n is equal to 2, that is 2 input neurons, h is equal to 2, 1 hidden layer and 2 hidden layer neurons, and m is equal to 1 output layer, and we are having 1 neuron in it. So this is what we are taking the input, and output we are taking it as the first one is part 1, initialization and weight updation. You can see that random weight updation we are doing. If you want, you can give the same weight updation as the problem which we have solved. Epoch, initially we have made it to 0. Then second part is feed forward back propagation and weight updation. Here if you observe, you can see that we will be finding out first zi in, then zj, then next one yi in with the formula, same formula, and with that we will be finding out y by applying what, by applying the sigmoidal function, binary sigmoidal function. Once we have done that, next step is back propagation. So in back propagation, what you have to find out, delta j k, then delta I in j. It is the same sequence which you have used, and then we will be finding out delta 1 I in and delta j of 1 and 2, and then we will be doing the weight updation here. Weight updation, new weight is equal to old weight plus the change in weight. Okay, that once we apply, we will be calculating the error. How we are calculating the error? Whether error is less than 0.005, that is our stopping condition. So each and every epoch will be calculated, and that will also be displayed. And what are the point that we are displaying? We are displaying the class, the PN class for total number of epochs, and display the epochs and error and everything, and finally updated weight matrices and bias. These weight matrices and bias should be taken for finding out, that will be the input for your testing data. That is nothing but in testing phase, what you have to do is the back propagation testing code, n equal to 2, m equal to 1, this one h equal to 2, same thing. What we are taking, load the weight and biases will be the same thing which we have updated from the training phase. Threshold also you can vary and see. Presently I have kept it as 0.5. Then we are giving the inputs, okay, and displaying how exactly it is working. What is the input? Z I N J we will be finding out, and we will be applying the sigmoidal function for that, and then we will be going with yin k, and we will be applying the sigmoidal function, that is activation function upon it. We will be getting the output y. Once we get the output, we have to display it, correct? So that display will give you, and once we are displaying, we remember that even the target you can display so that you can verify it. Okay, that's all. Any doubt anybody is having, please let me know, otherwise we'll stop. Thank you.